Okay, so keep going with the working with Kubernetes object section. We are now on recommended labels. So let's take a look. Recommended labels. You can visualize and manage Kubernetes objects with more tools than kubectl and the dashboard. A common set of labels allows tools to work interoperably, describing objects in a common manner that all tools can understand. In addition to supporting tooling, the recommended labels describe applications in a way that can be carried. The metadata is organized around the concept of an application. Kubernetes is not a platform as a service (PaaS) and doesn't have or enforce a formal notion of an application. Instead, applications are informal and described with metadata. The definition of what an application contains is loose. Note: these are recommended labels. They make it easier to manage applications, but they aren't required for any core tooling. Shared labels and annotation share a common prefix. app.kubernetes.io and labels without a prefix are private to users. The shared prefix ensures that shared labels do not interfere with custom user labels. So let's take a look on labels. In order to take full advantage of using these labels, they should be applied on every resource object. So we have the app.kubernetes.io name. It is the name of the application. An example is MySQL, and the type is string. You have the instance, that is a unique name identifying the instance of an application. Can be MySQL slash an identifier. You have the version key. It means the current version of the application. Can be a semantic version, revision hash, and etc. Here is an example: 5.7.21. You have the component, and it represents the component within the architecture. It depends on your architecture, but maybe a database. That is also the part of. It is the name of a higher level application. This one is part for. For example, can be a WordPress part. Okay, and that is also managed by. It's a tool being used to manage the operation of an application. An example can be managed by Helm. Okay, and last we have created by, and is the controller or user who created this resource. And this example we have here the controller manager. So to illustrate these labels in action, consider the following stateful set object. You have here the API version, apps/v1, the kind is stateful set, and here there are the metadata with labels. All the labels we just seen are just here in action. Okay, so application and instance of applications. An application can be installed one or more times into a Kubernetes cluster, and in some cases the same namespace. For example, WordPress can be installed more than once, where different websites are different installations of WordPress. The name of an application and the instance name are recorded separately. For example, WordPress has app.kubernetes.io/name called WordPress, while it has an instance name represented as slash instance with a value of WordPress and identifier. Okay, and this enables the application and instance of the application to be identifiable. Every instance of an application must have a unique name. So let's see an example. To illustrate different ways to use these labels, the following examples have varying complexity. First example, a simple stateless service. Consider the case for a simple stateless service deployed using a deployment and service objects. The following two snippets represent how the labels could be used in the simplest form. The deployment is used to oversee the pod running the application itself. Here is an example. You have API version app/v1, the kind deployment, and the metadata with labels. Here you have the name, my service, and the instance, my service, hyphen, and identifier here. Okay, and the service is used to expose the application. Here's an example: app version v1 kind service, metadata with the labels, and the app.kubernetes.io/name is my service, and the instance my service with the identifier here. Another example: web application with a database. Consider a slightly more complicated application. A web application, here is WordPress, using a database, here is MySQL, and this is installed using Helm. The following snippets illustrate the start of objects used to deploy this application. The start to the following deployment is used for WordPress. So here we have a deployment object, and here are the labels. Okay, name WordPress, instance WordPress, if identifier. We have the version, the managed by, in this case it's managed by Helm, and the component. Okay, the component is server because we have an WordPress server, and the part of we is how we divide. Okay, our application in this case is part of the WordPress application. Okay, and the service is used to expose the WordPress. Here we have a service with name WordPress, the same thing, WordPress identifier. We have the version managed by Helm. The component, this is part of the server, and the component, the component is server, and it is part of WordPress. Okay, and also the MySQL is exposed as a stateful set object with metadata for both it and the larger application it belongs to. Okay, we have here app/v1 and the kind stateful set, and we have all the labels: the name, MySQL, instance, MySQL identifier, the version managed by Helm, the component in this case is not system because it's MySQL, so the component is database, and part of the same system, WordPress. Okay, and the service is used to expose MySQL as part of WordPress. So we have a service here with all labels associated. Okay, so we have this stateful set, and then the service to expose the MySQL as part of WordPress. So with MySQL, stateful set and service will notice information about both MySQL and WordPress. The broader application are included. Okay, so that's it for today. Thank you so much.